Presentations here. Welcome again, and everyone new on the recording. Hi. My name is Oliver Gierke. I work for a company called Pivotal, and I've just like when I put the up-to-date GitHub thing in there, I wonder whether there are any like scientific research projects that look into how this thing here, how much that actually reveals about privacy or non-privacy. So I'm part of the Spring engineering team, which means and leading the Spring Data projects, which means that everything that's like data related and not covered by the core Spring framework is at some point in time passing my desk, and then we basically decide with a team of 4 or 5 people what to do with it. What I want to do with this talk is basically give you a whirlwind tour through the latest release trains of the Spring Data project. So I probably have to start with explaining what a release train actually is. But there's going to be a lot of code. I basically picked some of the examples that we have so that you can basically go ahead and play with them later on. But we're going to look at those examples, and then I probably try to point out the interesting bits in them. So what are the release trains? Spring Data itself is an umbrella project, which means that there's actually a couple of modules like physical. I mean, if you can even speak of physical in the software world, but physical artifacts that we produce that are usually modules that talk to or implement code for talking to different databases. There's a couple of infrastructure ones and the Spring Data REST module, which I've mentioned in the talk before. In the very early days, we've just like let every project release at their own pace, right? So there's a couple of those that are maintained by the core team, as I said, 3, 4, 5 people, but also a couple of community-driven ones, which basically means that it's not us maintaining them, but like outside contributors. And that turned, like with the project growing, that turned into quite a nightmare because like we had to make sure that everything is compatible to everything. So we basically introduced those release trains, that's nothing that we invented, but the Eclipse project, for example, is doing that. Like every year you get a new Eclipse release, right? We're not on a yearly cadence, but roughly half a year. But the key point being that at some point in time, we're going to release all the modules, no matter how many features went into the individual ones, and ship them. And by that, make sure that like all the modules contained in, let's say, the Hopper or Ingalls release train actually work with each other, right? That's also kind of important in terms of downstream projects like Boot, so that they can easily pick up those new release trains and whatnot. An important thing that we basically get with that is that while we're still trying to keep, let's say, user-facing APIs as compatible as possible between the releases, we usually take the liberty to upgrade the infrastructure requirements with these release trains. So when we release Hopper, we usually are on a certain baseline that's of both Spring Framework and like driver databases, JPA version requirements and whatnot, and we don't usually upgrade them within a release. We might pull in like bug fix releases, but you're never going to get, let's say, a major version upgrade within, let's say, a Hopper release or bug fix releases for Hopper. The Spring Framework baselines have usually been quite conservative. If you knew the most up-to-date Spring Framework version in August 2014, you'd realize that it was 1. We've usually been like one minor version behind the actual Spring release cadence. We sort of weakened that for Hopper already. The reason for that being, in the first place, has been that the Spring Data JPA module being the most popular framework by far, the most popular module by far, and relational databases usually used in more conservative shops that can't really or necessarily upgrade to the latest and greatest Spring Framework version. So we didn't want to cut off those users that, let's say, in this case here, were stuck with a Spring 4.0 version, even though 4.1 was still already out. We sort of like weakened that requirement because in was still the current production version with 4.3 coming out in a the, as you see here, that's the current production version. We are going to release a second bug fix release of Hopper next week or something, and we're going to raise the requirement for Ingalls, which is coming November, to 4.3, which in turn is currently the most recent version, the most recent production version. The reason for that being is that after Ingalls, we might ship another release train starting with J. You see there's some kind of alphabetic rule following here. We might release another release train, but there is going to be a Spring Framework 5 version in March next year, for which we have planned a much bigger Spring Data rewrite, revamp. Let's say we allow ourselves to break some things and improve things, and basically do cool new stuff. But that will be on the Spring Framework 5 generation. That will be on JDK 8. And that Ingalls version, or we might sneak in something J-ish in the middle, but it will definitely be the maintained for quite a while, because Spring Framework 4.3 will also be the 4x version. That's the last one basically, and that's going to be maintained for, let's say, the next 5 years or something. So, all right. Oof. What's that slide supposed to mean? As I said, we usually take the liberty in a release train, let's say for Hopper now, currently, to upgrade the individual transitive dependencies pretty radically, actually, because we try to stay on the most recent released versions. We're using that naming scheme because trying to create the impression of some kind of semantic versioning on the release train level is kind of a ridiculous attempt, because there is the Couchbase guys coming with a new Java driver with a rewrite, and then the next month there's the Neo4j guys releasing Neo4j 3.0 and rewriting Spring Data and Neo4j completely. So we basically, with every release, we sort of break the requirements, sort of, or require you to upgrade to something depending on which store you upgrade to, right? If you're not interested in the non-relational space and you're on JPA only, you basically don't care about that stuff. So for you, it's basically non-breaking. For everyone on Neo4j, it definitely is, right? So there's been like a couple of upgrades. There's compatibility upgrades with Hibernate 5. Which has been quite a bumpy ride, to be honest, and also the move from CRUD DSL 3 to 4. So the point here being, Hopper might be a release that might cause you to have to upgrade your some code in your application, depending on what module you're using. Also, the final thing down here, if you're using boot, then with boot 1.4, you basically get Hopper out of the box. With 1.3, you can upgrade to it by just like configuring a property. Or if you're not using boot at all, there's a release train bomb. Also, there's an example project for how to use that out there. But the point being is, that to actually pull in the proper versions of let's say Spring Data JPA. How do you find out about the version you wanna use for Hopper? The point is you don't, because you're just using the BOM and then pointing it to Gosling SR4 in this case, or right now it's Hopper SR2, and then you get all the right versions for Spring Data JPA, Spring Data Commons, whatnot, even without boot, right? So. All right, so I guess we're going to spend a couple of minutes on new features in Spring Data Commons, mostly for the fact that, or the reason for that is that those new features usually spread into the most used modules in the first place, which means JPA and MongoDB. We're roughly scratching the 1 million downloads per month number, so it's got to be like next. I'm looking forward to get the August numbers, really, because boot 1.4 has been released, and that usually a new boot release usually means like quite a bit more downloads in the Spring Data space in general. But the most popular modules are JPA by far, followed by Redis and MongoDB. So those stores usually get those features that we implement here pretty quickly. Sometimes the community modules, as they're maintained by volunteers, basically take a bit of time to pick up the features. All right. The first thing I want to show you is anyone, probably should ask that, does anyone not know what Spring Data is? Never seen Spring Data before? Okay, a couple of hands. So then I do the 5 minutes management summary. So on a top level, the question is, okay, how do you do data access for your data store? The answer that domain-driven design gives is you will introduce repositories because you have your aggregates and your aggregate roots, in this case my person, and the purpose of a repository is basically to simulate a collection of aggregates, right? So this thing could also be called like persons, maybe, or people, and then it will represent all the people, so you could find them, and it also usually allows you to select a subset of that from that collection. So you might want to access all the people with the first name containing something, right? And the idea here is that you can go ahead and just declare that interface, extend, or by some means make obvious that you intend that to be a Spring Data repository. That's usually done by extending a base interface, which also gives you a couple of new methods, like in this case, like CRUD operations, really. But that's just a side effect, really. You could just declare those methods yourself. And then you go ahead and besides those CRUD methods, you just add query methods, as we call them. And they can either use the query derivation mechanism, which means if you're not doing anything beyond declaring the method, we're going to inspect the method and basically try to do the right thing, TM. So in this case, do select P from person P, where P dot first name, and then with a like expression, translating that containing thing into, in this case, it's not even JPA, right? It's MongoDB. But we can do the right thing per store, right? We can translate that into a MongoDB query or JPA query, what have you. There's a couple of other features in here, like pagination and whatnot, but I don't want to go in there. The thing is that you can just do the simple thing when that simple thing is sufficient, but you can also, as you see here, declare your queries manually. You could just like write in a JPA repository. You could just like write your JPQL query there. There's support for query DSL for dynamic queries and whatnot. Going to get into that in a bit. The point I'm trying to get to here is that we've introduced support for Java 8 streams on the repository return type level, right? So what does that mean? You see, normally we just return like a list, or can return a list or an iterable or collection, whatever. The thing is, if you return a stream, that opens up quite a few possibilities, because that thing can be lazy, right? It's not that like implementing that support is just like calling that method, like, or doing the same thing as we always did, like read the list, right? Accumulate all the data, and then call .stream on it so that we return it. We're actually doing store-specific optimizations here. So let's say for MongoDB, and that's what I'm going to show you in the test, really. Have a look at the two methods and what they. There's like some test code in here, which probably wasn't supposed to be seen. But let's go ahead and let's like just oppose the two methods. The first call is executing a list-based query method, right? So it's going to go ahead and it saves some data into it and then calls the method, which means you see we fire some events here. There's like a couple of documents coming back from MongoDB, and we map them onto data objects, right? So we load that thing, we map it, we keep it. We load it, we map it, we keep it, like 2, load it, map it, keep it, 3. And then we iterate over these 3 and do some system out here, right? So we need to accumulate the list, we need to accumulate memory for 3 of these persons, and then can write them out. With the stream-based approach, we can like implement the repository method. Well, that's probably something I should have told you. The repository, you don't write the implementation yourself, right? The CRUD methods are taken care of by the framework, and also the query execution is also taken care of by Spring Data by default. You can override those method implementations if you want, if you need to. If the framework's not smart enough, definitely do so. But by default, you just like declare the method and you'll be done with it. See how this differs here, right? So we're not like reading the 3 elements into memory and then iterate over them, but actually return a stream. Actually, this thing here, this returns right here. And when the first element is ready, it's converted, there's output. Then the next comes in, it's converted, there's output. That's basically it. It sort of looks the same here, right? So it's kind of, that's the list-based access with just a simple for each. So we have to acquire the list and then handle the list. With the stream, we basically get a stream of person here, right? And you saw that thing intertwined. It's basically reducing memory consumption here and being slightly more efficient. We also do that, I mean, on MongoDB, it's quite easy to implement because you basically get a cursor for all the data that the query executes. And you can just nicely wrap that into an iterator and into a stream eventually. For JPA, it's slightly more complicated because JPA just exposes lists, right? So there's no only get result list, there's no get result stream, and I'm not sure we actually ever gonna get that. But the thing is, what we're doing there is we basically detect your JPA provider. So in case you're using Hibernate, Eclipse Link, or OpenJPA, we can then basically replace the JPA query execution with a slightly more sophisticated query execution using native store API, right? So we're going to use a Hibernate scrollable result set, for example, to actually do the same thing, right? Get the cursor and then allow you to stream the data, out. That's really it. So the other thing, let me check. There should be another one. Yeah, another thing that we've added, I just briefly mentioned that Spring Framework has support for using completable future as a return type, which basically means there's a, like with this at async annotation, there's a thread pool that actually executes the method. Which allows the caller or the call to return immediately, right? So when you call that method, you basically get a completable future, and the query is executed asynchronously. And completable future, in comparison to the ordinary future, allows you to compose logic on the results. So you're not like with the classical future, you would just like at some point in time say future.get. That's what we're doing here in the test case, but actually to wait for those things to happen here. But you can already, when you get the result, you can already say, okay, once you've done reading, right, you can then do something, right? So then accept, and this basically gets a consumer here, and you can do something to the result. So you're sort of tipping your toes into what's going to be some kind of reactive programming if you really want to go there. I mean, it's by far not reactive programming. That's not what I'm trying to say here. But the thing that's similar here is that you basically just define what is supposed to happen later on, right? So this step is happening without, like, if let's say the debugger is here, then the query doesn't necessarily have to be executed already, or that code even, right? So that's kind of a thing that you probably have to get used to once you're starting with that stuff. Yeah, it's just like test case logic, but the primary thing here being it allows you to sort of compose logic based on asynchronous method invocations. That's sort of it. All right. The second thing I'd like to get into is projections. So we've so far, depending on the store, you usually returned either the domain type that the repository was built to, or a subtype of it in case you're using polymorphic entities or something. But there hasn't been, until Hopper, there hasn't been a nice way to actually say, okay, here's this person domain object, it's pretty big. Actually, I just want a summary of first name, last name, and address, right? So that's basically what I want. And with Hopper, we actually introduced exactly that, or those capabilities. And we now allow you to go ahead and do the following. So while standard methods on this repository would have returned a customer, or if you're using JPA or something, you can use functions in the select clause, or you could explicitly have select certain columns, but so far you only were able to get back a map, basically a map of maps with that. What we've added here is that you are now able to express the data that you want to have using a projection interface. Which means you just like declare an interface. With Spring Data, we love interfaces. You've probably seen that by now. You just declare the interface and put what basically mimics accessor methods into the interface. So you say get first name, and for us that's basically the signal. Okay, you're not returning a JPA entity here. It's an interface, and we can basically make sense of that. So you want to read the first name property, right? So you can just like, in this case, we're just like issuing a find all query, but you can use add query here the same way I showed you before. But by you returning or declaring collection of customer projection, we basically know that the query that's going to be derived from that, it's not select C from customer C, but C.firstname from customer C, right? So we can project the query to actually that. And we can do that because that thing is what we call a closed projection. That basically means for every method you have declared in here is going to be a property access, right? So how that works internally is basically we just like project the query. So we get back a map of like all the first names, and then we create a proxy here that's backed by the map. And then we route the get first name call into a map lookup basically for the first name key. Simple as that. Right. So that's the closed projection. This is where we can actually do the query optimizations, right? So that proxying also works if you're just like reading the customer in itself. Then we just like route the get first name call into the get first name method of customer. What you see here is what we call an open projection. And the difference here being that this method is not, it's not like mapped to some invocation of the target directly, but we instead evaluate that spell expression on that method. So the add value annotation is a Spring annotation. You see that Org Spring Framework Factory annotation. You might have seen that like if you're working with Spring Boot, if you're referring to other properties, but you can also, or like when you're using Spring Security or something for permission properties. So what this basically does is it exposes the target object, the actual domain type as target, and then you can go ahead and just like arbitrarily access properties or combine code here. The effect of that being that if we realize you do that, we still need to load the entire instance, right? So we can't do the optimizations anymore, because to do that, we'd have to basically evaluate that spell expression and see which properties you're using, which is not something we want to get into. Also, this is an example here, and I highly recommend not to overdo that kind of stuff, because you're basically starting to program in strings again, which is a bad thing in general. What we usually recommend is, there's this mechanism of referring to beans. So you could go ahead and say, at my Spring Bean. So you can refer to a Spring Bean in your application context, and then you can have a method on there. And then you can hand that target instance to the method, right? And from there on, you basically back with Java code and Java compiler, and that method has to take a customer instance, and you can do like everything in a type-safe way. So whenever things get more complicated, rather use that than that. It's just like basically an example, and the point being, or the actual message here being that those projections can not only be used to slim down the amount of data that you want to return, but also enrich the data with additional computations and stuff like that. Because the funny thing, or the cool thing, is this proxy can just be handed to Jackson or like any serialization library, and it will just do the right thing, TM, right? So it will render a full name property with that value then like computed when you invoke the method here. So it's a very, very nice and flexible mechanism to shape the returns or the data that you want to return from that repository. Let me just like complete the thing here. So you see that also works with manually defined queries. The thing is here that you have to use, in the case of JPA, you have to use aliases, because otherwise we don't really know which field that you return is supposed to back which field here in customer projection. If you remember, that had a get first name method. Why do I actually list get last name in here? Oh, that's probably that's not needed here. But you can do that. There is the support for DTOs. So if you don't use an interface but a non-JPA managed class here, then we automatically create the right constructor expression. So that basically evaluates to select new customer DTO C dot first name. What was it? Was it first name? From customer X, right? So that's basically what we derive here. And to round things off, if you want to be flexible as a client in terms of like, okay, I know what I want to search by, but I don't know like what kind of view I want to have on that data, you can basically just like use a method declaration like this, and we will automatically find out, oh, there's a class parameter here that's bound to that return type, and that means you can just like hand in customer projection, and you get basically the optimizations with the one interface. You can hand in another interface, and you just like get everything applied properly. That's sort of it. Pagination still works. Yeah, that's sort of it. So generally speaking, projections are a cool topic, I think. On the repository level, actually those methods or that mechanism was introduced in Spring Data REST in the first place to just build proxies in front of the actual domain types to just be able to shape your REST representations quite a bit. And that mechanism is not something we keep to ourselves. There's a so-called projection factory interface that, let's say you have some other code where you want to apply those projections to whatever your maps or your entities. That's just like public Java API that you can use and then say, dear framework, here's the interface, here's my backing source like the map or something, and then create me the proxy. All right, query by example. Gotta hurry up. I'm wasting time. Query by example. So there's a couple of different, where am I here? There's a couple of different ways you can use the Spring Data repositories to execute queries, right? One you've seen before, like is where you statically declare the query and say find by first name containing, and then we translate that into a query that has the benefit of us being able to cache that query, to cache or to avoid unnecessary object or query, like especially with JPA where you go through the criteria API and have to like bind parameters and whatnot to cache that stuff. On the other hand, you sometimes want to go ahead and flexibly combine things like has a first name off and age is greater than, right? So, and then combine or not combine those things. And there's a cool library called QueryDSL for that. Come back to that in a second. That gives you like a type safe DSL basically for writing those predicates. And there's some ground in the middle where I just want to go ahead and say, guess what? I have an instance of that domain type here, and it's like partially filled with data. Just derive the query from that, right? So in this case, we use that new example API that we've introduced, which will by default just do an equals match on all of the properties handed in there, and ignore any null values, right? So whenever something is null, you basically express you don't wanna match on that. There is of course like a more advanced API where you can then go ahead and exclude paths from making it into the query. You can like check or change the general string matching into contains maybe, or contains ignore case. which is something people usually do. And there's also stuff where you can do that per property, right? So you can go ahead and say, here's my example, but guess what? I want the first name to be matched with a starts with clause and the last name to be matched with an ignore case clause. It's kind of a nice example. It's probably worth mentioning that Spring Data is generally Java 6 compatible, unless the store provider actually requires something different. But it's been like also in development of other features, it's been really cool to see how we can write Java 6 code that you on Java 8 can then use and pretty elegantly express what you want here. So Brian Guts, great job. Thanks. Seriously, if you ever meet that guy, have him a beer. It's really, really awesome work. Yeah, that's basically it. So we have support for that in JPA and MongoDB right now. There's really nothing preventing other stores from doing that. It's pretty simplistic, really. I mean, you can do quite a bit of stuff here, but whenever you find yourself wanting to do more with the query by example things, it's usually better to have a look at query DSL. So it's kind of a spectrum in between ease of use and power, as it usually is, right? And there's like certain features that we provide on each places of those spectrum we provide you basically options to pick and choose the right thing for the query problem at hand, basically. All right, query DSL web support, I already mentioned it. Has any one of you not heard of query DSL before? Who has heard of query DSL? Only very few hands, so I probably have to give you like a 20-second introduction. So it's sort of similar to the criteria API, except it's really usable from an applications point of view. And I deliberately phrase it like this because for us as the Spring Data project, the criteria API is actually quite decent. It has some quirks, but it allows us to like really easily implement all these kind of query derivation things. However, I've yet to see an application that really uses the criteria API in a way that like you can actually look at the code 2 weeks later and then still understand what the query is supposed to mean. So writing it is one thing, but expressing business predicates with that, especially it feels like you're always looking at code written by Yoda really, because it's like equal that date to the other date is. Right, so it's like always the other way around. With query DSL, it's sort of the same thing. You go ahead and you generate a query meta model, which you can do with the criteria API as well. I know that, but it gives you an API that looks more like this. Contains ignore case, foo, right? And I can assign that thing that's a Boolean expression, and then I can say expression dot and say user dot last name equals bar, right? And that's another expression. So just like try to do that with the criteria API. You can't just like do it from the meta model itself. You always have to have an entity manager, a criteria builder, and root, yada yada yada. So the other aspect being that this stuff is available not only for JPA, but also for MongoDB, for Lucene, you can even go ahead and just put some annotations on normal Java objects. They don't even have to be persisted. And then you can go ahead and say, I have a collection of these things here, and I can query the collection. It's kind of a funny thing to do, really. Go ahead.
The queue user, is that something you write? Or?
That's something you generate, basically. There's a Maven build step here. Just a build APT standard annotation processor that generates that class, which means that if you change the user class and the plugin like regenerates the user, the queue user, and you let's say have renamed the first name property, then you basically get those things not to compile anymore, which is the core point really here. So we've had support for query DSL for ages, literally. So you were always able to execute those Boolean expressions through a query DSL predicate executor. Welcome to the world of Spring class names. Interface. And the requests we got were like, okay, there is the wouldn't it be cool if we could just like have those properties here, those like first name and last name in a web request, and automatically populate a web request from like a predicate? That's the thing above here. That's the thing that we shipped with the new version, and basically say, okay, I want to bind request data that maps the properties of a user, and I want to get the predicate for that, right? And then you can basically go ahead and let me see if I can quickly run this thing. A boot app, Java application, and see if that works. That's MongoDB starting, and then go localhost 8080. And I get a form here, right? So it's just some arbitrary users basically, and I type, let's say, York here, and you see that the city basically gets matched, right? So there's like on the very top here is like basically saying address.city York, right? And you see that only York and New York match here. So you see that it's not an equals comparison, but basically contains ignore case, right? So where does that actually come from? Because the property here doesn't specify that. The mapping or the binding here will pick up a so-called query DSL binder customizer that has a method saying you get the bindings here and you get your root, like your queue user basically in this case. And then you can go ahead and then declare or basically configure the way the request data gets bound to the predicate, right? So we're saying here, like for all the string properties, we want to bind the first request parameter to contains ignore case. That's what we do. And by the way, we want to exclude matching on the password, right? Because you probably don't want to let like clients map on the or match on the passwords. I mean, I hope they would be only getting to match hashes anyway, but you can not only do that on a type safe way, you can also say root last name and then basically map or configure the binding for individual properties, again in a type safe way, right? Because we're using the query DSL meta model here. That's pretty cool. And like all you need to do to basically support such a form really is that line in your controller method. That's sort of it. All right, so we've got to hurry up. No time to summarize things. We do that in the end. So for MongoDB, let's go over a couple of store specifics quickly before I come to the gem I have saved for the end. There has been Spring Security integration for JPA for quite a while, which means there's an evaluation context provider interface where you can hook arbitrary functions into your manually defined queries. So we allow you to basically customize your JPQL queries with custom expressions where you can do things like return all customers if the user is an administrator, or only the ones he or she personally created himself or herself, right? So can do like sort of like security expressions in the queries. We've shipped that to MongoDB. Also, I mentioned that here explicitly. Usually I don't publicly not discuss because it's a conspiracy, but just because it's way too low level. But evaluation context provider is a nice interface that we've seen a lot of customers actually hooking into, because you can literally extend the query language yourself by spell functions, right? So in case you want to do anything fancy with the queries, go with that. 3.0 driver compatibility. There's a couple of different things in the GeoJSON and JavaScript functions execution area, but we'll probably just skip that for now. Okay, what's there in REST? A couple of things I mentioned in the talk before, like the support for optimistic locking properties being translated to E-tag headers. Also the same thing for less modified headers. That's quite interesting because it allows you to do conditional gets and put requests. We've also streamlined our JSON schema support. So again, Spring Data REST basically looks at your Spring Data repositories and your domain model and then exposes HTTP resources for that. That means we know what the representations look like, and we can expose a JSON schema for that. And we use that in the so-called HAL browser. It's just like a tiny JavaScript web application that we ship with Spring Data REST that you can just pull into your application, and you basically get a nice UI for exploring your APIs, and that also uses the improved JSON schema that we support here. So if you're into that, have a look at our HAL browser. Right. Redis. Oh, good thing. So the thing about Redis is, anyone using Redis here? Not too many people. Okay, Redis is a key value store, usually used as a cache. So you basically throw in arbitrary objects and just keep a key under which you've cataloged this thing, and then you usually just look those things up by the key again, right? That's what a key value store is about. The thing is that sometimes, for statistics purposes or for inspection purposes, you might still want to query the store. And let's say if you use it for session storage or something, you still might want to look up all the sessions that are older than 30 minutes or clean them up or whatnot. So far, you could map your objects onto the data store and create secondary indexes on those properties, but you had to do that yourself. And the thing is that with Spring Data Redis, with the Hopper version, we basically provide you that out of the box. So I'm probably just go through the talk, through the code here. Where is find by last name person? So you see that we have there's a couple of or a bit of Javadoc in here to explain what's going on. So you have these annotations here that we provide. Which, when Spring Data Redis starts, we basically know, okay, you will be querying on these things at some point, and then when you store a person, we basically create all the appropriate secondary indexes for you. That's something you'd have to do yourself manually. It's usually quite like a so what feature for people that are used to do things like MongoDB or Couchbase or basically any store that really deals with more complex data structures. But it's quite some effort to do that in Redis, and that allows you then to do the things that you're used to from other Spring Data projects, which is query derivation and executing the queries on those things, right? So it's literally two things. One is creating the appropriate secondary indexes, and the second is to actually execute the queries on that, and then basically rematerializing the objects for that. But I'd probably rather keep it short here. Right. So I probably also skipped the support for inbound projections here that we've shipped. We've seen the projection interfaces, just a couple of sentences on that. On the projection interfaces, I had these methods like get first name, right? And that basically was supposed to pull out the first name property of some database stored object. We also support that on the web layer in an inbound and outbound fashion. So inbound basically means I can read request data that way. So instead of having your DTO that gets a form bound to first name, last name properties, whatnot, you can use I'll probably just show that real quick. You can use an interface with both JSON path expressions and XPath expressions to selectively pull out data from the payload, which is quite important if you want to be reluctant or resilient against changes in the payload structure, right? So this thing here is basically looking up the first name and the last name property, no matter where they actually appear in the payload, right? So the client that's sending the data, if you were talking about inbound requests, could just move the first name field into, let's say, user nested first name or something. And we would still not have to change the API or touch our code at all, because that XPath expression would still find that property, really. So it's kind of about loosely coupling services to each other. That stuff might wander into Spring Framework, into core Spring Framework, once we've decided what to do with it. But so far, as it's sort of data related, we've like put it in here. All right, yeah. If anyone's interested in Cassandra, we're going to make Cassandra a core module. It's been a community module so far, and finally ship support for Cassandra 3.0. But all right, seen that. So the last couple of minutes, I want to use to just like briefly mention something that we've like currently working on the most right now, really. One thing, of course, is to make Ingalls a cool release, but that's what I didn't even mention. That projection part that I just showed you, the last part, that's part of the upcoming Ingalls release train and already available in milestone 1. So that's not like really released. It is released, but not in a GA fashion. Right, so we're working on that, and there is like plans for a Spring 5 release in basically March 2017. Which has like one of the big features is the reactive story here. So we're going to ship a reactive web framework, which means you can use reactive programming means, but still keep your sort of Spring MVC programming model with @request mapping annotations and what have you. And the underlying framework will take care of translating that into the means that we get with Servlet 3.1 it is, I think, or 4.0 then coming, or even reactive runtimes like Netty, depending on what you actually deploy to. But that basically means that you can write your controllers in a way that they use like reactive streams APIs, or we have our own implementation project of that called Reactor. And when you use those types and you basically get like this reactive call into your controller, the question is, what do you do with it? Like, how do you actually read data in a reactive way? And unfortunately, I mean, that of course requires the stores to expose reactive APIs in the first place, right? And unfortunately, it's not that like every store already does that. The Couchbase guys are like the top-notch ones, really, in terms of the support for that, because their driver is already built on those reactive APIs, so we can use those. But there's a couple of other like Redis, Cassandra, MongoDB, where we get reactive database drivers, and we're currently like working on making all the stuff in between like work for you. So what does that mean? With the Spring Data 2.0 or whatever, like the Spring Data.next thing, we're going to ship support for those reactive repositories, and we have working prototypes, as I said, for MongoDB. I mean, the thing is, it's also kind of a so what thing if you just look at it, because reactive person repository, if you look at it, you see it's sort of looking the same here. So instead of returning a person in itself, we return a mono of person. That's just short for a stream of one element, basically. Flux is a stream of potentially unlimited elements. But just those method signatures will allow us to actually, under the covers, use the reactive APIs of the data store and return this flux, and you will be able, from your controller or service method, just hand over that flux and just like add additional operators on that. So basically program what's supposed to happen with that person, right? Or with that flux here, if you just like render a collection of persons, we will invoke Jackson like on a item per item basis, right? So that you really stream through the data through your application code, and also using those method signatures allow you to apply this back pressure concept. Basically, like if the client is a slow one to read, you don't want to produce a lot of data, because that will just like cause your application to consume a lot of memory, but basically slow down the producer if the client is slow as well. So in a nutshell, with the story is just we're about to make sure that things just work as they've ever worked. That's a bit of a weird thing to work on, really, because it's not really a new feature, but it's probably the newest feature we could actually ship. One thing or one aspect here being quite problematic is relational databases. two key opponents, JDBC and JPA. Unfortunately, not because they're like bad APIs or anything, but they were never designed with that kind of programming model in place in the first place. So the problem here being that there are only, for very few databases, there are reactive drivers out there, and like for Postgres, for example, what effectively that mean we be back to coding against Postgres explicitly. The other thing is that a lot of applications are very much architected around the notion of the transaction, right? You do a request and then you change something, or you change multiple things, and they're transactional, and transactions just don't really make any sense in a reactive world, right? Reactive is all about avoiding to block on resources, and that's what a transaction is all about. Block the resource until we actually done with the work, right? So there's like we're still investigating options here, but so far it basically looks like when you're moving to that kind of style and to that kind of architecture, you probably have to rethink the way, or the data access technologies that you're going to have to use in the anyway. All right, so it's a good time for feedback. So there's a bug tracker, there's a wiki. We have a Gitter channel open for quite a while already. The slides are already up on SpeakerDeck. I gave this talk last week in Oslo already. If you want to go there, there's a blog post that wrote up. It's basically a summary of. It's also showing some other examples, but roughly what I've just talked about. The most important one is probably this one if you want to play with it. And we have a release train wiki where we basically document what will actually make it into the certain releases. And if you want to fancy it, there's a calendar because people usually just ask when are you going to release what, and like an iCal calendar, right? The most important thing to have, the spring release calendar in your iPhone. All right, that's it. Thanks for your attention, and I'll be around like until tomorrow noon, I think. In case you have any questions, just ping me and we can sort things out. Thank you.